Okay, so for the homework from the matrix powers of a matrix, I'm going to do 20a, and the question already told you what P was, but you still had to calculate P inverse, and from that you could figure out what D was. And that, well, normally we calculate the diagonal matrix by finding the eigenvalues, but they kind of try to go around this problem. Now, I don't want to solve it that way because it's not really how I would pose it. I mean, it's well a good question. I might, but for preparation for the quiz next time, I want to show you the whole calculation. So I'm going to do step one. Doing it like we did for previous time, I'm going to find the characteristic equation and the eigenspaces, etc. Okay, so characteristic equation, that's 1 minus lambda minus 2, 8, 0 minus 1 minus lambda, 0, 0, 0 minus 1 minus lambda. It's a diagonal matrix, sorry, a triangular matrix, so we can actually write the product of the diagonal elements here. Put this equal to 0, this would be lambda equal 1, this gives lambda equals negative 1, and this gives also the same. So we have again a potential problem, namely we need the eigenspace of negative 1 should have dimension 2. So let's figure that out first. Eigenspace for lambda equals negative 1, that means we're going to put negative 1, lambda is negative 1, put it in there. Okay, be careful, subtracting is actually really adding, so we get a 2, negative 2, 8, 0, 0, 0, 0, 0, 0. Look how nice, we're actually done, except for the 1 here, so row 1 and a half, row 1, and that gives me 1 minus 1, 8, and the rest is 0, so we have one pivot variable, x1, and the two other ones are free variables. I mean, sometimes it might be a bit misleading. You could be confused if there's only one thing like this left, right? But okay, so x1, x2, x3. We know that the last two are just themselves. So what is x1? Well, this equation tells me that it's equal to x2 minus 8 times, remember, bring it to the other side, right? x3. So this is x2, 1, 1, 0, plus x3, minus 8, 0, 1. Okay, that's my basis vector. Oh, people, hello. What? Okay, what are they wrong? Okay, I did this wrong, right? If I divide everything by 2 here, I get a 4 here. So this is a 4, and this is a 4. So the whole thing here is a negative 4. This is negative 4 here. Okay. And notice that this already gives me the first two columns of the P in the book. So we are on good track. That's why I knew I was wrong. And then eigenspace. You have to pay very close attention to what you're doing here. And okay, so lambda is equals 1. So we have to put in 1 now in this equation. So here we put lambda equals 1. We get 0, negative 2, 8, I mean in the matrix, I said equation with the matrix, 0, minus 1, that's negative 2, 0, 0, 0, negative 2, okay. Let's get as many ones as we can by minus a half, row 1, row 2 the same, and then row 3 even that the same. I get 0, 1, negative 4, okay, 8 divided by 2 is 4, okay, 0, 1, 0, and 0, 0, 1. Great, so we have this pivot, we need to make a 0 below it, so we do row 2 minus row 1. It would have actually been better to just switch row 1 and row 2, but let's go on. 0, 1, negative 4, 0, 0, 4, 0, 0, 1. Now I can divide this by 4, row 2, 1/4, row 2. So I'm going to do this now a little bit here, so this becomes a 1. And then I can do, so this is now done, right? So kind of row 3 minus row 2. Okay, I did. I want to copy the whole thing, so I get 0, 1, negative 4, 0, 0, 1. And then 0, 0, 0. Now we need still a 0 here because we have to be in row reduced form. The echelon, reduced echelon form, sorry I keep saying this because that's what people normally call it, but the book calls it. Okay, so the operation we do is row 1 plus 4 times row 2. And this gives me 0, 1, 0, 0, 0, 1. This tells me that these guys, x2 and x3, are the pivot variables and x1 is the free variable. So x1, x2, x3, well x1 is equal to itself, it's the free variable, but then this says x2 is 0 and the other one says x3 is 0. So we get x1, 1, 0, 0. And we do get, so step 3, we are now where the book was. The question in the homework problem was posed, we have P. And it's the same P that we had there. We take these two basis vectors there and we put them as a column, 1, 1, 0, 4, 0, 1, and we put this guy, it's 1, 0, 0. But we also know what D is because we know that this the first two correspond to -1. So -1, 0, 0, 0, -1, 0. And the second one corresponded to 1, right? Which I can, yes, lambda equals 1. 0, 0, 1. Great. Okay. See, this method tells me what D is. But in the book, what you had to do was, if you follow the question, the way it was posed in the book, you had to calculate P inverse first, which we need to calculate anyway. So, laser, I have no idea what the laser tail is. Oh, this means I can point. This is something I didn't know. I found something out, guys. I can now show you instead of. Okay, so P. Yeah, so I find that the inverse of this guy. Okay, by augmenting this with the identity matrix and then row reducing until I get the identity matrix on the left. Good. There's we need this one here, so we're gonna do row 2 minus row 1. That gives me 1, -4, 1, 1, 0, 0. So negative, we subtracting, so we multiply with -1 and add, so we get a 4, -1, -1, 1, 0. 0, 1, 0, 0, 0, 0, 1. Now I can make a 1 in the second row, but that's not really, then I have to do a fraction. I have a 1 in the third row, so why not use that and simply exchange the two rows? Okay, trying to avoid always fractions if I can. Sometimes you cannot. Or sometimes it's not worth the effort. Depends a little bit. And there's no good golden rule for that, so you kind of have to sometimes have to try and see what works best. Okay, but this is kind of obvious that this is much better because now I have to get, so I'm using this pivot to get the one below there, 0, the 4 below, so row 3 minus 4 times row 2. 1, 1, -4, 1, 1, 0, 0, 0, 1, 0, 0, 0, 1. So I'm multiplying this with -4, so I get a 0, a 0, a -1, a -1, a 1, and a -4. Okay, good. Then I need to change the sign in the last row. Okay, I'm gonna just do this and replace this row 0, 0, 1, 1, -1, 4. Okay. Good, this is echelon form but not reduced, so I need to get rid of this one, and I do this by the row operation row 1 minus row 3. Don't do anything else yet, one pivot at a time, right? So I'm doing that now. It is 1, -4, 0. So we're doing this with -1 and add up to the 1. So that actually makes it 0, that gives me a 1, and that gives me -4. 0, 1, 0, 0, 0. Where did that come from? 0, 0, 1, and 0, 0, 1, 1, -1, 4. Good. The only thing that's left is getting rid of this guy, so I do row 2 by using this pivot, row 2, row 1 minus plus 4 times row 2. So I'm multiplying this with 4 and add up. 1, 0, 0, that's a 0, that's a 1, 4, that's a 0 again. Get 0, 1, 0, 0, 0, 1, and get 0, 0, 1, 1, negative 1, 4. So this is the inverse, this is P inverse. Quick check, okay, let's check it. P inverse times P. This is a check again. I'm doing this so that I don't give you a wrong answer. So this is a way for me to see that I didn't make a mistake. And the way the checking is multiplying the matrix with its inverse, right? So the other matrix P, I have it here, so I can copy it. Minus 4, 1, 1, 0, 0, 0, 1, 0. And so let's work this out. 0 plus 1 plus 0, I get to 1. 0 plus 0 plus 0, 0 plus 0 plus 0. 0 plus 0 plus 0, 0 plus 0 plus 1, 0, 0, 0. 1 minus 1 plus 0, that's actually 0. Then I have minus 4 plus 0 plus 4, another 0. And I have 1, 0, 0. Yes. So I was correct. Good. So where are we? So this is step, well, I forget, lost track. Step 5, I guess. We know that the diagonal matrix is P minus 1 AP, and what we actually really want to use is the soft version of that, where the P's. But yeah, so remember this, the way this worked was because what I did is I'm multiplying here with P and here with P inverse on this side. The sides matter, so these two cancel. Okay, that's how I get this equation. Good. So we needed a to the power 1000, which looked like a horrible thing to do, but it's actually very simple here because this is the same as P d to the power 1000 P inverse. Okay, remember how this worked, right? Whatever power, this kind of thing, the powers don't affect the P because the P's keep cancelling each other out, the P and the P inverses. Okay, now what is d to the power 1000? Now d was minus 1, the diagonal elements were minus 1, and 1, right? So minus 1, and 1. So d to the 1000 was, I take the 1000 powers over that, but that's kind of ridiculous simple, right? It is because these are even powers, so this is just identity matrix. And if that's the identity matrix, then this is P inverse P, that is just the identity matrix. So the 1000 power was the identity matrix. Okay, so AB, it's to the power negative 1000, but it's the same thing. It's an even power, although it's negative, it's still even, and therefore we get the same result. So what would be 20 CB? Well, 20C, now we had the power 2301. You notice that once you have done this, you don't need to keep doing everything, right? So now you know that this is P d to the power 2301 times P inverse. But this, the only thing is that this is an odd power, so this is P d P minus 1, right? Because d, what is d to the power 2301? Well, that is minus 1 to the power odd power, that's just minus 1. So you get just, so in other words, let me say that. So what I'm saying is it is minus 1 to the power 2301, but that's just negative 1. And so this is also negative 1, and this is just 1. So this is just d. But I know what this is, because this is just a. I don't even have to work it out. Okay? So in some sense, this is not a good preparation for the quiz, because in the quiz I really need you need to still calculate this product. Here the product was extremely simple because everything kind of cancelled away. Okay? So this tells me that if I take this power of a, then I get just a again. But I think the other questions there that I solved gave you more straightforward way of working. Okay, so we have also a review for the quiz, so I'll do another problem that you see again how it works more in general.